We're going to be looking at the first section of the syllabus, which is information representation, and the subsection data representation. The focus for us today is going to be how and why computers use binary to represent all forms of data. Now, this is probably going to be a rehash of some of the information that you covered in IGCSE. However, there are going to be some unique aspects which obviously you need to know about. So let's start with the first difference. At IGCSE level, you probably worked with kilobytes, megabytes, gigabytes, and terabytes. However, at AS level, you'll probably find that in industry, there are two terms that are used. The first aspect is the standard international units, which are kilo, mega, giga, and tera. And then you have the binary units, kibi, mebi, GB, and tebi. The standard international units, kilo, mega, giga, and tera, are normally based on base 10. So you kind of go up with kind of like 1,000, you go to million, you go to a billion and trillion. And when we look at kibi, we go up in base 2. So this will be about 2 to the power of 10, which should be 1024. And then similarly, mebi will go up, and you end up with just a bit more data than a million. And a bit more than a billion, and then obviously a trillion. It is vital for you as a computer scientist to know the difference between both units and how the everyday common person will probably be using kilobytes and megabytes. However, what the difference is with the actual units, which stand for kibi. And it makes a big difference when you're dealing with memory. For example, kibibyte means you get a bit more storage space, a bit more space is required in the memory compared to kilobytes. So let's look at how two people will deal with it. So on the left hand side, we've got our amateur, and on the right hand side, we've got our professional. Their interactions together based on what kibi is and what kilo is and how confusing it all gets will give you an idea of what challenges people face when they're talking about memory and storage capacity in kibi and kilobytes, etc. So our amateur goes that, okay, I know that computers work with electricity. And the expert is, well, not quite really. Computers actually use binary, and electricity can be turned on or off. So that is equivalent to base 2. When the electricity is on, we have the digit 1. If the electricity is off, it's 0. So the amateur is like, okay, well, I think that 1,000 is a kilo, and that's a kilobyte. And the expert goes, well, in base 2, we use something called geometric sequencing. So we go up in 2, 4, 8, 16, 32, 64, 128, 256, and so on, until we reach 1 or 2, 4. And that is known as a kibi, 2 to the power of 10. So our amateur goes, well, I still think mega is 1 million bytes. And the expert then goes, well, actually, it's 1,048,576 bytes, which is also known as a mebibyte. So they're slightly different. Even though for small amounts, it's not a big difference, but when you equate all these megabytes into bigger numbers, it can add up to a sizable sum. Our amateur goes, well, why the two different approaches? And the expert goes, because of the SI, which is the system's international units, and to make it easy for non-experts to remember all of these are called decimal prefixes or base 10 prefixes. So prefixes are basically words which you add in front of a number. In this particular case, kilo is a prefix to bytes, and mega is a prefix to the bytes. So these are called denary prefixes because they operate in base 10. The amateur goes, well, now I am confused. GB is still gigabyte, right? And the expert goes, well, yes, that's right. However, GIB is gigabyte. And a 1 GB hard drive will be smaller than a 1 GIB hard drive because obviously there's a lot more space in the gigabyte hard drive version of things, which is based on base 2 and is a binary prefix because it operates to 2 to the power of something rather than 10 to the power of something. Our amateur goes, okay, So 1 TIB is less than 1 TB or terabyte. Is that correct? And expert goes, yeah, you got it. 1 terabyte is equivalent to more than a trillion bytes, or 1,99,511,627,776 bytes to be exact. So hopefully you got a good idea about what decimal prefixes and binary prefixes are like. And decimal prefixes, remember the term prefix means adding something in front of a number. So in this particular case, when we use the standard metric system for prefixes, they tend to be kilo, mega, and giga. And the decimal system increases in orders of thousands. So 1000 gram is equal to 1 kilogram. And we use something similar, which most people are familiar with in their day-to-day life. Now, why did this happen? Well, it's because consumer is king. And this was all great when storage capacities were very tiny. So in the old days, we never used to worry about like megabytes and gigabytes. People used to work with bits and bytes, and storage capacities were so tiny that decimal prefixes seemed normal. But as storage increased in size, unfortunately, that caused a bit of a problem. However, still, 1024 bytes was close enough to 1000 bytes that we could get away with things. But as memory capacity and storage capacities increased, things started to become difficult for both software developers and manufacturers themselves. So here's an example of this. This is an ad for a 10 megabyte hard disk in the old days. However, how do we know how big this is? Is it 10 million bytes? Is it 10,485,760 bytes? Who knows? And that caused a problem for consumers themselves as well, because they didn't know what they were paying for, or what did they get. It was pot luck. And of course, these days you probably won't pay $3,495 for a 10 megabyte hard drive. These were expensive items, and it made sense to be exact. So what was the solution? Well, the solution, of course, was binary prefixes. The industry decided to get their heads together and come up with a new prefix system that uses binary units to avoid all of this confusion. And back in 2005, the IEEE, which if you kind of look them up on the internet, the Institute of Electrical and Electronics Engineers, and they came up with this new standard. So they said, well, we're going to be using kilo binary, mega binary, giga binary, and tera binary, which in short form become kibi, mebi, gibi, and tebi. The symbols are as what they are, so the bytes become, instead of kilobytes, they become kibibytes, and so on. In an exam, you might be asked to equate between both of these units, or you might need to work out something in megabytes or mebibytes. So when you're working with megabytes, and if that's what the answer requires, you do 4 times 1000 times 1000, which gives you 4 million. And if you're working with mebibytes, you go with 4 times 1024 times 1024. You've got to be careful, and you need to check the required unit to work out what the answer is. So are people actually using binary prefixes? Well, change is always very, very slow. And if you look at operating systems like Microsoft Windows, you'll probably see that Microsoft is still using bytes, even though they're equating the answers using binary prefixes. They're still referring to the end result as denary prefixes. And this change is prevalent throughout the industry. However, people are trying to change step by step. Things will change. At this particular point in time, you should try your hand at this particular worksheet. See if you understand the difference between both decimal and binary prefixes. And you should try to work this out physically instead of using a calculator. Perhaps use 2 to the power of 2 or 10 to the power of something to get those longer calculations shorter. There's a few questions on screen which should take you about 10 to 15 minutes to do. So have a go, pause the video, and perhaps see if you can apply what you've learned so far by solving these questions. Okay, so some of the key terms that we've used so far are binary, which is a base 2 number system, 0 and 1 only. Bits, which are obviously short form for binary digits, and obviously the terms binary prefixes and denary prefixes, which are a set of letters that precede a unit of measure, such as a byte, and the binary one indicates multiplication by a power of 2, and denary indicates multiplication by a power of 10. And another word that is quite common is to know what the magnitude of a number is, and that's the actual value of the number. Okay, we'll stop the lesson here for today. Hopefully, by now you're familiar with the syllabus itself, and if you're not, I would probably suggest download it and have a look through that. You've completed a worksheet. If you haven't, please go back and do that. It's very useful to practice these. I'll try to put these type of questions in the future videos as well, so you can just practice what you're learning. And of course, have you signed up to repl.it? And if you have, fantastic. The other thing I want to add here is that you might want to start an exercise book for note keeping and perhaps use the Cornell note taking system. It's fantastic. It's proven to be one of the best ways to summarize knowledge. Look it up. It's just fantastic. That's all I'll say. Okay, that's all for now, and we'll catch up in the next session, which will be focusing on programming.